So hello everybody. This is use case number 3, paraphrasing in news reporting with deep neural networks. I remind you that we are recording this session. So just to let you know, in case you just want to switch off your camera and microphone. For questions, we are going to use the chat. So please post the question in the chat when you want to ask something to our presenter today. I'm going to wait some seconds so more people have the chance to join in. So before introducing our speaker for the session today. So for everybody, I will present myself only briefly. My name is Macarena Beigier, and I work as a data science consultant at a company called Modellagenten in Berlin. And I'm happy today to host this session with Sebastian Duerr, who is a machine learning engineer at MIT Center for Collective Intelligence. He focuses on natural language processing and generation. And he collaborates with a company called Narrativa.com to integrate NLP deep learning solutions into their service offer. So Sebastian, thank you very much for presenting today. And I remind everybody who wants to ask questions about the presentation, please use the chat. Thank you, Sebastian, for being here today.
Thank you, Macarena. Thank you so much for the introduction. I quickly share my screen with you. If you could quickly give me some feedback, Macarena, if you see something.
Yes, I see you loading. Yes, that's fine.
Perfect. Okay, then I assume that everybody can see it. Thank you again for the introduction. So today we're going to look at paraphrasing in news reporting. This is a use case that I collaborated on with Narrativa in order to have the Wall Street Journal getting a bit more creativity into the reporting that they do. Firstly, let me show you where you can, like different domains or sectors, where you can actually integrate NLP solutions. So you have life sciences that Narrativa is serving. So let's say you have trials and you have to write the reporting for that. Obviously, this can be automated with AI, respectively deep learning. Then in the financial service industry, there are lots of solutions or opportunities to use NLP or NLG, marketing and e-commerce. And lastly, here on the slide, media and entertainment, on which we're going to focus with the use case today. For that, I brought an example. So Narrativa.com is a Spanish company. And like one of the fields in media you can automatize a lot when it comes to like text production is soccer, because obviously it follows a certain pattern. And Narrativa does that. And not only for the Primera División, like the first league in Spain, but also like the second, the third, the fourth, actually all of them, whoever, whatever the client wants. And this example briefly like introduces how this kind of works. So it's like leading to the service that we implemented with paraphrasing, but I come to that in a second. So imagine you have a soccer event. So a popular one would be possibly Barcelona playing against Real Madrid. And we would know that, they play 9 p.m. In Camp Nou, the stadium. And then Narrativa would actually check and pull data on a recurrent base from providers of soccer data, like Resultados Football or Sports Radar. Not only this works in soccer, but also in other fields such as like sports such as basketball, rugby, whatever you can imagine. And then they pull the data into the data sources, and immediately, and obviously in an automated way, we then operate on that, meaning it gets into Narrativa query, what you can see in the middle, symbolized by the lambda. And there some pattern analysis is done. So things that we as humans don't naturally know, like how many goals did Messi score in this season, or what is the current streak, like the number of consecutive wins of, let's say, Real Madrid throughout the last few matches. This will then be integrated as data and like updated depending on the forthcoming on the game between Barcelona and Real Madrid, let's say. And from there, like this knowledge is then being integrated into Narrativa's knowledge graph, which is the infinity symbol down there, the real-time alerting system. What is done next? It's getting into the natural language understanding engine, which is the part where I'm working on with some microservices that I built. So in this area, you try to really mimic the style a certain press outlet is using. So when you think of Wall Street Journal, for instance, or Bloomberg in the US, that would be obviously in English language, and it would be very business heavy kind of. Whereas the soccer news on the 4th division in like a Spanish local newspaper, maybe a bit more objective, like stating what was happening in a more like subtle way. And yeah, so in order to mimic that, you kind of look at things such as sentiment, you make sure the correct tense is used, and also that paraphrasing is being done, because technically, obviously, texts usually don't alter too much when it comes to what we would say or consider like rather straightforward use cases, such as in soccer text generation, whereas in other domains, like reporting on different business events, it may become more difficult. And then you really want to mimic the tone. And that's happening in this module. And like in a moment, we're going to see how that can look like, or how this is being implemented. Before that, we quickly go on to Narrativa NLG, the natural language generation service that kind of combines like what he gets from the Narrativa query and the natural language understanding services, and it creates like these semantically independent text pieces. So let's say we start off a text, a report about this match between Barcelona and Real Madrid, and we say, yeah, Real Madrid is coming to the game with 6 consecutive wins in the last 6 matches. This would be semantically independent of a similar text pertaining to Barcelona, because yeah, you could say it without the other team. And then with some heuristics, we actually integrate then semantically relevant aspects in this field, and then we ship it directly to the customer. This happens in 2 ways. It can be published directly as an XML feed. So technically, from something is happening and we get the notification from Resultados Football to a tweet, can happen in an instant. Or if you want to have a full report on how the match was, let's say the next morning or like that night at 1 a.m., then this is also being waited for the match to end. And then like all these patterns are being integrated and shipped to the customer. And this is all happening automatically. And yeah, not only with like popular matches, but also in the 2nd, 3rd division if needed. All right, so this is kind of the landscape that you have. And now in a moment, or on the next slide, we're actually gonna see how paraphrasing can help, you know, to spark some slight creativity when it comes to text generation. So yeah, I usually start with the result in mind. So before explaining you how we did it, here you can see such a microservice. This is a simple paraphrasation microservice that for which we fine-tuned T5. And this is like has the mere task to generate 10 sentences and then like give us 10 examples as paraphrases for this query. So the query is: shares for Tesla went up 5% due to impressive presentation by CEO Musk. This could kind of be like a use case of Bloomberg, let's say, or any other media outlet. And then you can see like T5 immediately gives us back like 10 examples. And then, okay, it's a loop, so I have to wait until you see the example. Here, shares of Tesla went up 5% due to impressive, went up. So it adds articles, it sometimes changes the order a bit. Here it says thanks to. It really adds some creativity. This right now is very low because we want it to be successful and reasonable. But if I would play, and this is just a gift, so I can't right now, with this factor here, the top p-value, then I could make the neural net much more creative. Sometimes with reasonable, but also sometimes with unreasonable or rather funny statements, as you can imagine what AI can do. So yeah, but how do you get to that? How can you paraphrase whatever sentence you have? That's actually quite a straightforward process. So we took the deep neural net model based on the transformer architecture T5 from Google. It's open source, everybody can use it, and it's pretty impressive. It has been trained on 745 gigabytes of data, so it literally read a lot. And through this, it learned how language works. And Google ships this deep neural net with a few downstream tasks. Downstream tasks are like text summarization or translation. So you can translate with it from English to German to French to Romanian and other languages. And it also does have two more features to which we come in a second. And so what you usually do, you do not really build from scratch such a deep neural net, but you would use one provided by usually like the big companies such as Facebook or Google or Microsoft, because it's really, really expensive to train these neural nets, meaning it takes like a power plant to run or to train for a week such a neural net. So what we do, we use their publicly available service. And then in this case, we took a data set called the pause data set. And this comes with paraphrases. So you have a statement and you have another statement, and professional annotators checked that these statements are actually meaning the same, but they're using different words. And they did this not one time, but 50,000 times. And so what you do, you show these 50,000 examples of paraphrases to T5. And through the repetitive task of fine-tuning and seeing these examples, by already knowing a lot about the word, it has seen already 800 almost gigabyte of data, it really starts to understand what a paraphrase is. And then we also added like this little prepend paraphrase to this data set. And then after training, which only takes a couple of hours, you actually get a T5 model that learned a new skill. So whenever you tell it paraphrase, and I did nothing else on the slide before, and I give it a prompt, then it gives me what you've seen, like one of these 10 sentences or 10 sentences at the same time. And that is the first step. But as we did this, for instance, with the corpus of Wall Street Journal, we actually wanted to sound and make the paraphrases sound like the business narrative that Wall Street Journal is usually using. So what we did, we got a corpus from them, which was actually kind of small. And we showed it again to our, and that's why this neural net here is red as well. We showed it again to this red T5 that already knows how to paraphrase. And we had these 500 something sentences from Wall Street Journal. And so what we did, we actually told T5 paraphrase, okay, now you can paraphrase. So why don't you paraphrase these 500 statements and actually create new paraphrasing pairs? And yeah, that's what we did. And through this, we created a new data set, like kind of this paraphrasing data set pause in a proprietary way for our client. Yeah, we didn't stop there. So what we did next is, how do you know that these sentences are reasonable? On the slide before, you've seen if I choose a high top p-value, then they're kind of reasonable. We can assume that, but we also want to have this creativity in order to write very like interesting texts that don't sound the same. Specifically, also in fields like soccer, where you want some some like fresh ways of saying things. And so we actually used T5, the basic version that we got from, or the standard version that we got from Google again. And it also comes with two features. One is sentence similarity. So this kind of evaluates how close two sentences are. And this is pretty useful if you have two paraphrases. You want to check that what your neural net that is fine-tuned creates and how similar it is to what it has used to create this like new sentence. And also we use the feature of COLA, which stands for the Corpus of Linguistic Acceptability. And this is a data set where professional linguists, so not me, took 10,000 examples and of text, and they said if it's semantically correct or not what is written in that statement. And so we used this feature that T5 has and also checked if our generated texts, like the ones you've seen earlier, make semantic sense. So we checked the similarity and we checked like the semantic and also syntactic sense. We actually had a quite a high quality gate, like only like 13 sentences were rejected, like being not reasonable according to this evaluation metric. And so we could, move on with our created data set. And what we did ultimately, in order to really have paraphrases that sound very, very much the way a company like Bloomberg, or in this case, Wall Street Journal, is talking, we showed these more additional 480 something examples to the T5 paraphrase, so the red one that already knows how to paraphrase. And then it really creates now statements that you, or at least I, and my colleagues at Narrativa, the people I'm collaborating with, can distinguish between, like, has it been written by a bot or has it been written by someone from Wall Street Journal? And through this feature, we can like improve this, text production and mimic the style, as I mentioned earlier, in a process like the soccer reporting. That's what we did. This is kind of like how, like, I shipped then this feature of paraphrasing and put it into a so-called microservice. So you literally send a query there with your word or your sentence, as you've seen earlier, and it returns you like different options. And this is kind of the way how it looks if it's integrated, or when it's integrated into a Narrativa system. You've seen the feature earlier. And to conclude, I just want to say that I think use cases like these really show that, you know, if you use such a service, you absolutely can increase the productiveness of your news reporters, because they do not have to think a lot how they paraphrase a certain statement. We've all been there in our bachelor thesis and our publications that we did for potential PhDs, etc. You know, like often we think about how to rephrase a statement that we really like, but we obviously want to say it in our own words. With such a tool, you can actually generate a text, and then you can evaluate which one you like the most, and therefore save some cognitive capabilities to move on to the next such example. What I found or find personally absolutely amazing of like what deep learning allows us to do these days is it can give us data and like insights that are beyond our human knowability or capabilities. Meaning, of course, some people may know how many goals Messi scored in the current season, but what about League 4? I may not know it, you may not know it, but the system keeps track of it. And so you can actually report that as well. And no one has to count it like on like a recurrent base as it used to be in the past when I used to play soccer a couple of years ago. Now it's being done automatically. And all these like microservice architectures, like the one that I just introduced to you, yeah, they're pretty dynamic and flexible. You can just integrate them and quickly ship a sample to your customer, to your client. And yeah, I think such benefits like really change the way people can do their jobs in a way that, you know, they enable, they allow you to be even more productive than they used to be. Yeah, that was my quick introduction on the use case. Thank you very much for attending the session. In case this was a bit too fast, in the lower part of the slide, you can see a link on Medium to Medium, where I wrote a blog article about this. And like there are also all the training materials that you need in order to replicate what I just did, except obviously for the data that we got from our client. This I can't disclose, but I guess you can get very far pre-training on your own corpus, your own style. Thank you.
Thanks a lot, Sebastian. It was super interesting what you just presented to us, and also very important that people who want to know more in detail about what you just present can go to your link to the Medium post and also use your research and what you've been doing for their own use cases. I remind everybody that if you want to ask questions to Sebastian, please use the chat. I'm going to start myself with a question to break the ice and encourage everybody else to also post their questions. So I was wondering, because what kind of performances do you have in other languages, right? Is this different if you do it in English, in Spanish, in German? How does it work?
Interestingly enough, in the last couple of weeks, Google also released one of their architectures, MT5, which stands for Multilingual T5, and this even allows you to do, let's say, paraphrasing in other languages. So since Narrativa is Spanish and they work on the Spanish market, almost everything is being produced in the Spanish language. So we even explored with that. And since I'm native German, I also looked into that, and I can tell that performance is good, but you definitely need more of manual brain capable or brain cells to make it perfect. Because yeah, there's a big difference between English texts and German texts, or Spanish text production,
Sure.
just because almost all the text in the world is written in English that these models are trained with. Yeah, but there are attempts to do it, and I don't know, you can I guess find ways around it. For instance, by translating a Spanish text to English, make a paraphrase, and then translate it back. I guess this would be a quick and dirty solution to actually do this in a proper way. Or
and it obviously works well because you are already doing that in Narrativa. So and you've been successful with Spanish with that. So I move to the questions from the audience.
Thank you, Macarena.
So Darina says she wonders about the original soccer statement that that you're paraphrasing. Is that already machine generated as well? And how do you decide what an interesting statement to generate?
So when it comes to well, one disclaimer, I'm really researching on new tools like the paraphrasing tool. So and colleagues or other employees at Narrativa would actually implement then my service. So I've seen all of that, and I can give a brief option or statement in this regard, but I'm not fully aware how the code is being written, let's say on a code level. But as far as I've seen, yeah, there are, so first you usually start with old newspaper articles from back in the days where people have written text with their hands or with their computer, and then you take that and you train a neural net with that, and you replicate with a text editor. You replicate the statements, and then with paraphrasing you can actually start creating more creative texts. And technically, what you always do is before sending it out to any client, because they don't want work that is not of quality, you check in multiple tests, as we've seen earlier, what does the neural net actually do. And yeah, with playing with the hyperparameters, you actually at some point really see how it can even fascinate you with insights that you weren't aware of just because you didn't think of that. I hope this answered your question. Thank you.
Yeah, for sure. Also, another question, if there is any type of human reviewing in submitting the products in the text to the clients, or is it there is some form of quality monitoring and feedback built into the pipeline? That's another question.
As far as I'm informed, there is for sure, because you want to provide high quality text that are comparable to what, or like maybe even outcompeting what humans are able to do. So there are redundant quality gates, and also dependent on the data file, human annotators, or what Narrativa calls automation editors, that would review certain pieces before they go into press. And yeah, what I know from colleagues at Narrativa is that the client themselves usually wants to have a look, since, you know, there is this trust, but also not this full trust established now in what technology can do, I guess.
Yeah, not probably managers are not yet used to that, right?
Right.
Another question is, does the paraphrasing work for only small text, such as newspaper headlines, as input?
So technically, this neural net T5 allows us to use up to 512 tokens, which is approximately, depends on how long the words are, but you could see it as 500 words. And I think 500 words are like an essay of one page. So no, it works on much longer texts. And then there are also neural nets like Reformer or Big Bird that has been released in December by Google, which would allow you to create text and paraphrases on as little as 1 million tokens, which is an entire book. It's insane. It's moving very fast and could run on every 16 gigabyte graphic chip, which is not really a lot in terms of computing power. So yeah, you can modify a lot and paraphrase lots of text.
So another question from Marcus, is step 3 quality about filtering out statements that don't have the expected quality, or does step 3 actually change the sentence?
Thank you for that. In this case, we just like I was doing different experiments, and I just started like so I created this additional paraphrases, and then I wanted to know how good is that actually. So I just ran like inference. So I created paraphrases on these 500 initial statements, and I realized, okay, it's pretty good. Like there are only like a few sentences that don't really are amazing. So I just kicked them out, because technically you want to avoid manual labor, or you want to avoid the process of repeating that. Although I could have done that for sure, but yeah, in this case, since it was a small fraction, I was like, it's not worth even continuing with that. It already looks very good, like what we got as results.
Also, I have a question. I understood for what you mentioned that the final corpus that you use to fine tune is provided by the client, by the customer, right?
Yep.
So
So
that would,
pause. Yeah, excuse me.
yes, so that it would fit very well, or the idea is to fit the kind of language, or whether it's formal or informal text, or small sentence, right? Or this type of
Exactly. Yes. Yeah.
text.
So pause is more a data set that is being that allows you to, or that looks like short story sentences, like ordinary text that you read here and there. Whereas yeah, like business text is more of the example that I showed you with like indices of stocks and what else.
I think people are also wondering if this also works for longer text, like a whole
Definitely.
article or something.
Yeah, no, it absolutely works. It's for that you want to make sure that I think you read it already after, but yeah, of course you can do that easily. Yeah,
That's great, and
it just
it's
doesn't fit.
really. No, please go
Sorry,
on.
it just doesn't fit on one screen. So I just a short example so that you can actually read it. Yeah.
Yeah, of course. I think it's fascinating, especially language that's something so complex, and so relevant for human interactions and for human being, that it could be automated like this, especially in some in such a sophisticated topic like paraphrasing, and it works very well. So this is really amazing, and I'm sure we are going to see much more of this development in the next months and years. Well, we have to wrap up. It's time to finish. So thank you very much, Sebastian, for your interesting presentation, and for bringing us this very relevant topic at the moment. I also want to thank the audience for the interesting questions, and for being here. I remind you all that we are going to have another data lift event by the end of March, on March 26th. So I hope I can see you all there again. And again, Sebastian, thank you very much. And thank you very much, everybody. And I hope we all stay safe and have a nice weekend.
Thank you very much. Thanks to all of you, and goodbye.